All right, let's talk about URL class. So this is fun stuff. So there's a class in Java called URL. So URL, Universal Resource Locator, this is kind of the backbone of the web. So we mostly use HTTP : // but that's an example of a URL. There used to be other things we would use, FTP : file : mostly it's just HTTP anymore. So there's an example of a URL. So this is a machine. Okay, this is the name of the machine. clark.edu, example.com. So this basically maps to an IP address somehow. And then on that machine, we have things that this relates to. So for web pages, the usual meaning is that there's some particular directory on the machine that's the root of the web server. And when we say domain name /docs/resource1.html, it means go to that root directory, look for a folder named docs, look for a file called resource1.html. So you're basically browsing a directory tree remotely. Now, in some cases, we're being very explicit about that. In other cases, we're not. So here I'm just looking for twiddlenick on the Linux server. And that means look for a file called index.html. That's the default file that it will look for. And it will bring up my web page from the server, which is what you see here. And if we control U, we can see the source code. And this is the actual file, index.html, on the Linux server. So it's a markup language, HTML. So we have some tag and angle brackets, bunch of information, and the same tag with a slash in the front. And that's the beginning and ending of that block. So the whole thing is an HTML block from here down to here. And we have one line, which is the title block. So the title is hello, and the slash title says that's the end. And that's why this tab is labeled hello, because that's the title. And then the body basically says everything else is the main stuff that you want to see on the web page, and it's just a bunch of text. And I wrote it on separate lines, but when it displays it in the browser, it comes out on one line because new lines don't mean anything by default in HTML. Right, this is the actual file. So if I add an extra line in there and I come back here and I refresh the page, right? So it's pulling information in from a file on this remote machine. But this is all that the web is, right? When you go to news.google.com, you're basically going to a particular file which is being updated in real time on the server, and you're getting a bunch of HTML. And your browser simply takes this information and uses it to display this particular page. Right, so it does formatting and changing font and size and all the good stuff that we're used to with web pages. So the URL class is a class in Java that understands how to request things from a server using this Universal Resource Locator model. And when we construct a URL, we can specify a string, which is the representation of the page or the resource we're after, so http : / etc. And once we have a URL object, we can say something like open stream. So we construct a URL, and it's kind of like constructing a file. When we say new file parentheses something, it doesn't do anything with that something. It doesn't actually open it. It's just creating a file object and saying the name of the file we're after is this. Same thing with the URL. We construct a URL. It's saying, okay, here's the address of the resource we're after. But when we say open stream, it actually opens a connection to that URL. So it'll go out to the web and it will look for typically port 8080 or 80 in the old days, and speak some protocol using a client-server model and try to find a page with whatever you put in the URL's address. And so OpenStream causes all that to happen, and it returns an input stream. And input streams, we know we can use that in the constructor of a scanner, and once we have a scanner, we can say has next and next, or has next line and next line, and so on. So we can put this all together and do something like this. So here's my URL. I'm constructing it with my fancy homepage on linuxengrcs.com, twiddleneck. I'll call the OpenStream method on that. That gives me an input stream. I'll use that to construct a new input stream reader, and I'll use that to construct a scanner. And then I'll just do our usual scanner loop while SC has next line. I'll call the next line, and let me put something better here. And we'll just print out what these lines are that we get back from this scanner. Yeah?
What's the throws exception? I don't think I really fully understood that from last lecture.
Ah, we didn't really talk about it. So we should put this in a try-catch block. Okay, because when you try to open this thing, it might not be something you can connect to. So the way we've been talking about doing this would be like this. Well, this can throw an exception, right? Malformed URL exception, so if this is not a valid string. And this can throw an exception saying that we can't open it. So I should put that in a try-catch, I should put this in a try-catch, and then my program's twice as long. So the other option is just to say that the main method itself can throw an exception. And now we're telling the compiler, or the system, that when we run this method, main, we understand there could be an exception, and we're okay with that. We're fine if this thing says exception when we run it. Otherwise, it forces you to handle it by doing a try-catch block. And if you want to be able to handle any kind of exception, you can just say throws exception, and that'll throw it for anything. All right, so if we run this, it should open a connection to the server, the web server on the Linux machine. It should look for a page under my home directory /public_HTML/index.html. And I should have access to that through the scanner object, and this will loop, and it will read the contents of it. And so if we run that, assuming I haven't lost my network connection, which I might have. Oh, there we go. So there's the output I got. So you can read web pages from Java, and it's a few lines of code. Construct a URL object, get an input stream, and either read from that or feed it to a scanner or whatever your favorite input method is, and it serves it up to you. Yeah?
Does it work with URLs that aren't yours?
Yeah. It should.
Like, could you read, like, just Google Clark?
Well, let's try Clark. Now the problem is the security stuff can make it interesting. Well, let's see what it does. Whoa. Didn't like that. Maybe it's not secure. There we go. It's not an HTTPS. So here's what you get when you actually go to clark.edu. Well, I saw welcome to the Penguin Nation. Yeah. So it's a lot of JavaScript, right? Like most modern web pages, there's Welcome to the Penguin Nation.
It's been like 20 years.
Clark College is the oldest institution of higher education in Washington, blah, blah, blah. And then all the things you can link on, those are hyperlink references. So these are what all the different things link to: faculty, staff, foundation, and so on. So yeah, we're scraping the web using Java.
So it looks like the Clark College Foundation is the only one that's complying with Google's push for.
Yes.
security.
Yeah, and whatever ECD is, continuing ed.
Wouldn't you only need HTTPS if you had a login form or something on that page?
The problem with HTTP is it's susceptible to spoofing, I believe.
Mhm.
So it's possible that you think you're at http clark.edu, but it's actually something different. And if you do HTTPS, there's some public key, private key stuff that I don't quite understand that helps validate this is actually who it is. Which is why sometimes when you go to an HTTPS, you get a warning saying, this doesn't look right, do you want to accept the certificate as is?
So it's literally like a third party says like, this is your server, you're the one who owns it, and
Yeah.
then anybody else who gets it gets their client key, and it's like, for anybody who's ever been a web admin, it's frustrating setting up SSH, you know, like all those keys.
Yeah.
It's a nightmare, especially now everything's required to have,
Mm-hmm.
unless you want your site to have big red warnings in every single browser ever.
But on my website it was easy because I paid $6 and they did it for me.
Actually,
Just check the box.
Encrypt does it now for free.
Yeah.
So, but, you know, it's just like it's a encryption and security thing, but now you have to do it. No
Yeah,
matter what
yeah.
website you run, whether or not you have transactions.
That's fine. That's good then.
So let's take a look at this. So here I'm going to twiddlenick/shared/223/rect/rec.java. So what is that? Right, this is that area where I post code from the course. We get the fast connection today.
It's that router.
Hey, I unplugged it, man. It wasn't me. This even finished uploading, so I don't know what the problem is. All right, there we go. So we can come into rec.java, and in this case, it's not HTML, it's just a file, right? And it understands that there's no markup language in here, so it just displays it as text. So if we want access to that from Java, exactly the same thing. Just construct your URL with that constructor, and when you run that, we've got the sample code for the rectangle class. So this goes along with this whole object mindset, right? We have this single class URL that can do all of this stuff, and suddenly it exposes all of these pages to us, right? And we can grab web pages from anywhere. And it's still just a protocol, right? Underneath, it's making a connection to a particular socket on the machine we indicate here, and it's following a handshake that is HTTP in order to access the page that we're asking for. Yeah?
How difficult is this to even see?
It's a little harder, but you can find libraries that bundle this up for you. It's very easy to do in most languages like Perl and Python and things like that. C is older, so you need to find a library that has this functionality, but they exist. To do it directly in C, right, no harder from doing it directly in Java. You make a socket and bind it to that address and bind it to port 8080 or port 80, depending on the protocol, and you send a message like get in the name of the page, and it starts shoving HTML back at you. And it's pretty straightforward. But with objects, right, once that is understood, you bundle it in a class and you're good to go. So we can grab pages, and that's fun. What else can we do? We can find our closed project option. There we go. So JEditor pane is another Java class. And this is a text component to edit various kinds of content. Could be plain text, could be HTML, could be rich text format. So JEditor panes understand HTML. They will understand those tags in the markup language and interpret them appropriately. And you can construct a JEditor pane with a string, which is a URL, or with an actual URL object. So we can put these together and get something running pretty easily. So here's my main JFrame. I've got a single button, and I've got a JEditor pane. Okay. And it's sitting inside a scroll pane, which means if I try to display more than what fits in here, I'll get scroll bars automatically. Okay, that's part of the scroll pane class. So the Go button does the following. It sets URL equal to, and in this case it's setting it to a new URL constructed on that shared area in my directory. And then I use the following method, webpane.setPage URL. And setPage says, read that page's contents and use that to display the contents of this content pane.
This is a browser, isn't it?
So this is a browser.
The editable is false.
Yeah, I don't know what would happen if I made editable true, but you got to make it false for some reason. I think you can make it true, and you can just change the. Yeah, we'll make it true. Why not? Yeah, we'll hack Google here. So we'll run this, and I'll hit the Go button, and we wait a few seconds, and there's the shared area on the Linux server, and I can scroll through here and see all of this, and it's all good fun.
You can click on it
And I can change it. Yeah.
Oh my god.
Yes.
So if you go to
The way it
Chrome,
should have been.
does that change extra reflect?
Better not. False. It wasn't me. All right, so the other thing we have in here, if we right-click on this, there's a method called hyperlink update. That's an event that I've added a handler for. So what does this mean? Hyperlinks, right? Things that are underscored, things that are tagged with href, hyperlink reference. And when you hover over that or click on it, it triggers an event. And in this case, it's an event called hyperlink update, right? So it creates a listener for that. And it passes it an argument, which is a hyperlink event, calling it arg0 here. And so I can say if arg0 get event type equals hyperlink event dot event type dot activated. That's what happens when you click on a link. So if you click on a link, I'm going to print a message which says click, followed by the get URL method of that argument, which will tell me the URL of the address that you clicked on. And then we'll go one better. We'll go ahead and we'll call the set page method, and we'll say set the page to that URL. So this code right here and here, this will make these links clickable. So there's our window. We can open this up. If I click on this, it'll show me that I clicked on that link, and it actually changes the contents of the page to the 223 directory. And I can click on the rectangle, and I can come down to main.java, and there's our main code.
So can you go to something like prettier and it'll look the exact same?
You don't think my website's pretty, man?
Well, yeah. I mean, like just something way more complex. Like, you know, the Clark website or something. Stuff with pictures and
Did you make a web browser in like 10 minutes?
Yeah, so let's go to apod.nasa.gov. That's the astronomy picture of the day. And we'll click go. And astronomy picture of the day. Where's our picture, man?
Beautiful solar system.
Yeah, I bet it's loading.
this is still better than the Windows Edge.
Do they have a link to the image of it?
It should be loading, but I think it's slow. Let's try this.
Wait, that loads in. Oh, okay.
We'll let it sit for a minute, because I believe it's loading. And this will be really cool. but we have pokey connection. Anyway, this does work because I tried it at home. And you get pictures and stuff like that.
Do you ever get the same thing in the email about someone's PA? It works at my house. So.
Yeah, totally.
Works on my computer.
I don't know why it's lagging though. So let's.
I will say that this is a video for the picture of the day.
Is what?
There's a video.
Oh, okay. That might be an
That
issue.
might be why.
So let's do clark.edu and see if we can get lucky.
So do you have to add something else to like view picture or videos? Right?
Yeah, because this is just looking at HTML. So let's see what this gets us. My disk is grinding. There we go. So there's Clark's website. Now this is kind of the raw HTML version, right? So it's supposed to be running JavaScript to make things pretty and all of that.
That was what I was trying to get at.
Yeah, so none of that's going to happen unless we make. But we got some pictures, right? And we got a penguin, so all's good.
Is there a way to get that JavaScript to be working?
There's other classes that'll do that.
Okay.
But not the JEditor pane itself, as far as I know. And this will happen more and more, right? But it's too bad we can't get this. Let's try one more shot. Try Jupiter season, Hawaiian sky. Oh well, we'll let it grind. So suppose you wanted to add a back button,
Yeah, this is a video.
so you can like go back to previous pages you've seen. How would you do that?
Save your previous URL.
Stack, save your previous URL. That's really all there is to it.
Could you even add a favorite button? That, like,
Add a favorite button. You could add bookmarks.
Oh!
Hey, here we go. All right, we got the moon. We can scroll this way. We can scroll
Change
that
your-
way.
change your constraints.
Yeah. Yeah.
Oh, was that yesterday?
I think so.
I was right.
June 3rd. Yeah. So yeah, if you want to save your history on a stack, right? You create a stack. There's a class for that. Make a stack of URLs, and each time that you click on something, take your current URL, push it on the stack. Each time you hit the back button, pop the top of the stack, use that as the argument to your set page, and bingo, you've got a back button. If you want to record a history of your pages every time that you visit a page, add it to a linked list. And when you click the history button, display a page that shows you just a list of all string versions of the URLs. And make them clickable. And if you click on one, use that to set the page, and so on. So this is the point where I say after this, it's all just programming, okay? And that doesn't mean that it's trivial or not worth, spending your life working with. But the really hard work is already done in some ways, right? Well, the backbone of the really hard work is already done. You have a class you can use to make URLs. You have a class you can use to display HTML, and so on and so forth. As programmers who are well versed in objects and object-oriented methodologies, right, you get to use all of these goodies and put them together to do whatever it is you want to do, right? So it's just programming / creativity, right? So nobody's ever invented a favorites page before, and you've got this idea of let's keep track of how many times you visit each page, and let's show you a list of the top 10 pages that you visit, right? And you can code that. And it's not that much code, right? It might do something fantastic that nobody's ever done before, and that you sell to Google for $1 billion and you retire. But it's not that much code, right? It's the concept and the ability to execute on it. And that's really kind of where you're going with all of this stuff. It just unleashes this huge world of possibility. And to me, that's the real fun of all of this programming, especially in 2018, because we've got so much stuff out there. Who went to the talk on Friday in the engineering club on Alexa? Nobody from here. Oh, oh yeah, good. Yeah, so Bruce was in. He was talking about Alexa and showing some of the code on the backbone. It's the same thing. You write a few lines of code, and he wrote something that he could say, Alexa, read me news from Clark College, and it would go to the Clark website and look for the news feed and read stories to him, right? And all the infrastructure for that is there. Amazon Web Services is there. You can get a free account. You can do like 1 million transactions a month for free, and it's really just using that and adding a layer of code that you come up with to put some additional capability in there. And this stuff that we're talking about now, right, cuts across platforms, it cuts across languages. The client-server model, it works for Java, it works for C, it works for Perl. It works on a Raspberry Pi, it works on an Arduino, it works on a $5 Internet of Things board that you can buy from Amazon, right? All this stuff uses the same protocol, it's standardized, and I can have an IoT for $5 that talks to port 8080 somewhere on a $1 billion server and has the same experience as, you know, some corporation's huge network running enterprise level software, et cetera, right? Doesn't make any difference. It's still just bits. So this is where it really gets fun, right? And this is where I hope you find some jumping off points into whatever it is that you're excited about and you want to do. So you can like redo your SLP really fast and resubmit it. No. But you get a chance to do capstone projects and things like that after Clark. So hopefully all of this is like worthwhile for that. All right, so let's see. Let's talk about jars. So all right, there's a rectangle class.
I just skip over words like that.
W, like that?
Yeah.
Yeah, that's a W.
You're just cruising.
So here's our circle class, right? And it's an integer world, so area of a circle is just 3 times the radius squared, because I don't like typing double. So, well, that kind of like, here we go. Back in my groove. All right, so we've got a rectangle class, we've got a Java class. And if you look in our directory, we've got 2 class files, circle and rectangle. Okay, so let's make a main program. So we'll make a circle, we'll make a rectangle, and we'll just print out their areas. Okay, nothing startling. And then we can run it and it does its thing. All right, so here's an interesting dilemma. Suppose I don't have access to circle.java and rect.java. I just have my main method here, main.java, and I can compile that up, and I get all these errors saying it can't find a symbol for rect, it can't find a symbol for circle. Now normally when you compile something, it will look in your current directory for class files that match what kind of class you're trying to construct. But in this current directory, the only thing I have is my source file, main.java. So in this case, my class files are sitting in this other directory called good. And I want to compile my main class, and I want to use these class files, but I don't want to copy these class files into my main directory, right? I want to point to them somehow. So this is like when we say -lm to point to the math library, right? So there's this idea of a class path which says what directory should I look in to find classes that I need. And by default, the class path is your current directory. But if that doesn't contain all the files that you need, you can specify an explicit class path. So you can use the -class path switch, or you can just say -cp. So I'll say java-class path good, which says look in the good directory, and I'll tell it what to compile, which is main.java. And now it compiles fine. So I've got my main.class, and I can say Java main, but it complains because it doesn't know about the rectangle class. Why? Because the rectangle class isn't in my current directory. So again, I need to say Java-class path good to say, hey, look in the good subdirectory for classes that you need. But now it's complaining it can't find the class main. Why? Because main.class is not in that directory good. So I've got to tell it, hey, there's two places you should look for classes. Look in my current directory and look in the subdirectory good. It's going to look in my current directory to find main. It's going to look in good to find rectangle and circle. And now it works fine. And this is what you've been doing in your labs when you compile. There's a -cp or a -class path in the directions. And you specify a ::, and then you specify not a directory, but something called a jar file. But that's basically what you're doing, is you're helping the Java virtual machine know where to find the classes that it needs. So this works fine as long as you have access to those .class files. But if you have 100 .class files and they're sitting in 15 different directories, this gets to be a really long Java statement. Okay, so there's something called a jar, which is a Java archive. Right, what's a tar? Remember what tar stands for? It's a tape archive. And R is just an archive. So this is a Java archive. And it's really just a zip file containing a bunch of class files. But it's not, it's a jar file. So jar create verify file, or let's go into my good directory. So jar create verify file, shapes.jar star.class. So I'm creating a file called shapes.jar, and the stuff I'm putting in that jar are all of my .class files. And I'm creating it with the C, and I'm saying v verbose with the V, so it tells me it added circle.class and rectangle.class. And now I've got this shapes.jar, and I can say jar, show me the table of contents on shapes.jar, and it'll show me what's in there, and there's a circle and a rectangle, and it creates these other meta files. Now, if I give that shapes.jar file to somebody, whoa,
You have a movie on there?
Yeah, Kazan.
I have a lot of movies. Which movie?
Kazan.
Oh, that's what's being recorded right now. No.
No,
That's unfortunate.
It's probably fortunate, because I'm posting it. So now let's get rid of. So I've got my main.java. Okay, let's get rid of main.class. All right, and let's get good out of here. So now all I've got is my main program, main.java, but I've got this jar file. Okay, so here's what I can do. I can say java c dash class path. Actually, I don't even know if I need it. Let's see what it does. Yeah, so I need to say dash class path dot colon shapes dot jar main dot java, and it will look in that jar file for class files that it's missing. And then when I want to execute, I can just say java dash class path dot colon shapes dot jar main, and it'll go ahead and run my code. So if you've created something with a bunch of classes and you want to distribute it, you can put those classes into a jar file, give that jar file to someone, and that's all they need to be able to use those classes in their own code.
Is it like a makefile almost?
It's kind of like, well, you could put a makefile around this to do this. It's the result of something like a makefile. It's kind of like an object module, or what we would call a library. So like the math library under C is a collection of functions, sine, cosine, square root, that have been compiled and can be linked in with your code. So you write your code and you call the square root function, and if you specify the name of this math library when you compile, it will pull the definitions of those functions from that library. That's what the dash LM switch does. It actually passes the name of the math library to the linker. So this is how we can share code and distribute code and so on and so forth. So let's go back into Eclipse. And let's see if I can find this speech. Oh, it's going to give me a hard time, isn't it? Yeah, I'm not going to do that. What?
What's the Sudoku class?
It plays Sudoku.
I know, I think somebody asked that before.
We can look at it later.
it just prints a message that says something like it's spelled Sudoku, not Sudoku.
Yeah, right.
My mom used to say Sudoku.
Yeah, it goes through all the possible combinations and solves puzzles for you. And I think it generates puzzles randomly too. I had someone who was wanting to learn Haskell for an independent project. And so they were doing this in Haskell, and I threw one together, and
It is
let's see.
Count Sudoku?
I feel bad reading your file.
Why?
I don't know.
Hash
Then
browns.
don't.
Yeah,
They're on video, so you can like scrutinize them later.
You can like start heckling them.
Yeah.
You do like
Comment
half
section.
You know what half friends does?
It creates brown hash.
They're delicious.
All right, so here's some code. I wrote this in Eclipse, but it's not going to play nicely in Eclipse because I wrote it on a different Eclipse. But the reason for that is a lot of this stuff was generated for me. I didn't write most of this code myself. Eclipse did. But this is trying to tie into a speech generation module, okay? And you want to work with a piece of code. You want to do GPIO on a Raspberry Pi, or you want to do speech synthesis from a Java program. You find documentation for what's called the API, the Application Programmer Interface. And an API is typically just a set of methods that you're going to call that do different things. It's documentation that describes what these different methods do, how you initialize, how you use them, how you deinitialize, and so on. And a lot of times they come with sample code, and a lot of this code was just ripped from the API for this particular speech synthesis module. So init takes the name of a voice that you want to use and does all of this. It basically searches for a synthesizer that knows how to use that voice. So it goes through a list of possible voices, and if it finds a voice that matches the one you want, it exits and uses that to set the voice. I don't need to know what any of this stuff does, right? But basically I'm just using different methods inside this synthesizer mode description class, and this central class, and this was the key to get it all working. And it's gibberish, right? That's okay. Terminate you call when you're done. It shuts down the speech module. And then do speak is something that takes a string and it calls the speak plain text method in the synthesizer object, speak text null, and that will cause it to talk. And then you wait until it's finished, I believe. So here's the main program that I wrote. Woo, all 6 lines of it, right? So I create a new main object, and that main object, that main class is up here. So I create a new main. I say initialize to the voice Kevin16, okay, which is a low quality male voice. And then I call the doSpeak method and I give it some text. And then I terminate. So this is all like, because I don't remember this stuff. So here's the path to the jar file that contains all of the relevant classes. All right, so I downloaded this along with the API documentation. And so we can say java c-class path dot colon this thing, main.java, and cross our fingers, and it compiles correctly. So we'll give ourselves some volume. And then we can execute it.
This is a test.
There you go.
Attention. Long dialog detected. Please check the chemical maps.
And there you go.
Creepy.
So, yeah, creepy. So, especially in the middle of the night when I don't know the volume's up and something happens. It's like, so, tons of these things out there, right? Someone in the other section is doing an SLP on a brainwave scanner, and I loaned them a brainwave scanner that I bought, and it's got a Java API, right? So you can read the API, download the jar file from the web, link up to it, and you got access to all these classes. I had this little gizmo I bought a few years ago. I can't remember the name of it anymore, but it's a infrared sensor, and it basically reads hand gestures. So you put this thing into a USB port and you put it on your desk, and if you put your hand above it, it will give you information about where your fingers are, the angles of them, what position your hand's in, and so on and so forth. And so you can read hand input, and you can use this to make, you know, the things you see in sci-fi movies where you like swipe through displays by waving your hand and so on and so forth. And it's all a Java API.
Make your own theremin.
Say what?
You can make your own theremin.
Yeah, yeah.
You could translate ASL and then
pipe it into the.
Oh, totally, yeah. I was hoping someone would do that, actually.
That would be crazy.
Yeah.
Actually, Google is working on the same project.
Yeah?
They have a chip that can read your ingester.
Oh, cool.
Like, you just plug it somewhere and do stuff.
Nice. It's probably better than the $50 one I bought from Best Buy. So yeah, all these things, right? It's kind of a standard model for an API. The specifics depend on the particular thing you're working with. But if it's got a Java API, which more and more things do, you already know how to get into it, right? You just need the specific documentation on the methods inside the certain classes, and you just tap into that through your code. So this is all there for the taking. All right, we got 10 minutes. Let me show you one other example of a client server that I did in the other section. So I was doing some work several months ago with this chemical-based learning system that I've been researching. And I wanted to see if we could teach this system to play a game. And so the game we were working on, I guess we being me and the computer, was a lunar lander. So how many people have played Lunar Lander? Yeah. So so when I was in high school, this game was available on our computer. It was not a video game. It was just printing out lines of text, right? And basically you have a ship, and it's falling under the pull of gravity, and you can apply thrust that will apply an upward acceleration, but you only have a certain amount of fuel. And your goal is to try to land on the surface of the moon at as low a speed as possible. And if you landed more than, a few feet per second, you explode and everyone dies. And so you tell it where you want the thrust to be, and you say step the simulation for 1/10 of a second, then you can change the thrust and you step again. And on the version I first used, right, it was just printing out speed, altitude, location, that kind of stuff, and you had to sort of figure out from there where you wanted to turn the thrust on, more or less, and so on. So I was trying to evolve this chemical computer to play this game, to be able to land this ship efficiently. It actually ended up doing a really good job at it. But in doing this, I had this set of code that was all done in Java, right? Fairly complex. It's this weird, unconventional computing system. And I wanted a population of a number of these systems, and I was going to let them do random things controlling the ship, see how good a job they did, in other words, how big the impact was when they crashed, pick the ones that did the best job and somehow combine them to come up with a new population and just evolve it over time. So the setup was I had all this code over here that was this evolutionary system, chemical-based computer, and so on. And somewhere I wanted a simulation of this ship landing. Okay, I didn't want to embed that simulation inside all of this stuff. Okay, the simulation was just one thing sitting over here that I just wanted to hit again and again and again. Classic client-server setup. So the simulation of the lander, the thing that's saying how fast are you moving, how much fuel do you have left, set that up as a server. Okay, so that runs like this. And you get this window, so here's your ship. Here's how much fuel you have left, here's your current speed, here's your initial altitude. So we're 200 up, not moving at all, fuel is 200, and we're going to fall under gravity. And there's a port number we can specify, and we can say start, and it'll listen for connections on that port. And so normally this was done in Java, but we can play with this manually by just telnetting to localhost, whatever port, 1213, and connecting to it, and just establish a simple dialogue protocol, okay, like you're doing in Lab 5. We've got a way to send characters by pulsing these lines high or low. Why? Because that's the legal way to do it? Because that's some standard? No, it's just what we decided to do, right? Same thing here. So real simple protocol for controlling the ship. So if you send an uppercase T, it turns on the thrust, and you get the little thrust symbol there. If you send a lowercase t, it turns it off. If you say S, it says step the simulation. And now you can see the speed has started to increase a bit. Our altitude has dropped a bit, and our fuel is staying at 200 because we're not using any thrust. And if we keep doing this, eventually the altitude gets low enough that we start to see the ship coming down. So now we're at 190 meters or whatever, and the ship's falling, and we can turn on the thrust at this point. And now we're going to start slowing down, but we're still descending. And the thrust will counteract gravity somewhat, but it's going to take a while. And I can use a D command which says dump out your status, and the server sends back to me a single line telling me, is the simulation done? No, that's false. How much fuel do I have left? What's my current speed? What's my current altitude? So through this interface, right, we're doing this with Telnet, but this could be a module inside this evolving system, and it makes a connection to port 1213, and when it wants to turn on the thrust, it just sends an uppercase T. If it wants to turn it off, it sends a lowercase t. It can step the simulation by sending an S, and it can see what the current parameters are by saying D, and that feeds into the evolutionary system, and it makes decisions on whether to turn the thrust on or off. And that's what it was trying to learn, is how to connect this information to how to control the thrust. But the point here for this class is, right, we've got this separation of functions, right? And this is a classic way to use a client-server model. Have something over here doing all this stuff, but over here is the thing that's doing this slow, kind of expensive visualization, in this case on a separate thread, but it could be on a separate machine. And I can just send a request over there saying, go ahead and step the simulation and dump back the variables. And this could be displaying some beautiful 3D picture, or it could be a flat picture like this, or it could be headless. It could be doing no graphical output at all because it's running on a server somewhere. And I don't have to change anything in my code over here, right? So that's just kind of a slave device that gets requests, sends things back. And that's a really useful model to be able to use. And you know how to do that because it's just sockets, right? So send information, get information back. And developing this was really easy because when I developed this, I just used Telnet to drive it and to see, you know, here's what my current speed is, 12.725. Is that what I get back from my dump? Yeah, that looks good. And you kind of go like that. And you can quit. All right, so you're armed with all kinds of good skills and knowledge. That's pretty much what I was hoping to get through today. So Wednesday, we will talk about C++ and or Android, depending on whether I can get Android to play nicely. Maybe, depending on whether or not I spend time on it. So we'll talk about that, and then next week, Monday, you'll do your PA5 presentations. Wednesday, we'll do review. And then we're done. So, coming up to the end.
Put up with us for 9 months.
All right, I'll see you next time.
Well, then we had some other classes.
Server,
So